Hi dear followers, welcome back to OfficerAerospy channel. So today in this lesson, we will define and understand the major terms of mass and balance. This is the continuation from the previous lesson, which we defined the center of gravity and how it affects the total mass of the airplane. So now on the loading operations of an airplane, that constraints are placed on the limits of travel laid down by the manufacturer. So we use the airplane flight manual, which is stressing the factor of forward as well as off limit, which exceeded can cause the serious effect on the performance of the airplane. The center of gravity will move in the flight due to the fuel as well as the crew members and the movement of the passengers. So the initially the center of gravity is calculated and contained within the four and half limits all the time. We are now defining the datum balance R. So this balance R moment is very important components for calculating the center of gravity. And let's start with the datum, which is fixed point along the longitudinal axis of the airplane, as illustrated here in the diagram. And the position is set by the manufacturer as the zero or the reference point, and the measurements are taken in determining the center of gravity position, the datum line, and which can be located anywhere on the longitudinal axis of the airplane. I hope this is understandable. Now, the balance R is the distance from the datum to the point where the mass is under consideration and acts vertically downwards. And it is very important by using the balance arming calculation and vitally important to have the conviction that arms forward of the datum are negative. So let's say the mass is 8,000 kilograms, the movement becomes 80,000 kilogram meters. And it is very important to know that the movement forward of the datum lies negative, and conversely, it would be the positive. The positive movement is 8,000 kilograms per meter, and the negative is 1,600 kilograms meter. Okay, so the total moment will be considered by multiplying the moments, and we must sum up to end for the 78,400 kilogram meters, which is a positive, and eventually dealing with the sum. There are the some high numbers which are involving the movements. So life has been made very easier because the operator uses the loading index. So let's understand what exactly the loading index is. So loading index simply can be done by dividing the moments by a constant, thus reducing the moment to 1. That is much easier to use. For example, let's say this table of contents can be addressed at the moments which are divided by the constant of 1 million. For the first line of the table, you can see the basic empty mass moment of 22 million, and 10,7854 kilograms inches is divided by the constant 1 million, resulting in the index of 22. So this is how the items and the index is calculated depending upon the mass as well as the R.